Hello and welcome to another one of D's ADD videos. Today we're going to look at some derivative examples, just see how we're going to work these problems out. So the first one's just an example of the power rule. You're going to multiply this 4 times the 2, and then you're going to subtract 1 from the exponent. That'll give you 4 times 2 is 8. 2 minus 1 is x to the first. But we don't need to write that 1 up there, it's implied. So you could write dy dx equals that, or f prime equals that, whatever you choose to write there. Now this problem here, next one, number 2, is to illustrate that if you've got multiple terms added and subtracted, such as this polynomial, then you can do them individually. Derive, again, just multiply and subtract 1. So that would be 45x squared minus 25 x to the 0, right? Because 1 implied minus 1 is 0. Anything with a 0 is 1. And negative 25 times 1 is negative 25. And then again, this is a constant. Any numerical value has no rate of change. So in other words, it's always derivative of 0. So in this case, this would be our answer for f prime. Alright, the next one is to illustrate the fact that the power rule needs to be on top, and just have you practice this algebraic rule that for some reason a lot of the calculus students forget. Anytime I have this, I can rewrite it as this. So if there's nothing there, there's an understood 2 there and an understood 1 there, so it's x to the 1/2 on bottom. And then when I bring it up, it becomes 6x to the negative 1/2. That's not doing any calculus, pure algebra. So that's it's a positive 1 on the bottom. And then when you bring it up, rewrite that so it doesn't look bad. So when you bring this one up, it becomes minus 3x to the negative 1. And then plus 4x to the negative 3. And this fraction here, using this a over b method, the b is 3, the a is 2, so this would be negative 2x to the negative 2/3. Again, why is it negative? Because it's on the bottom. We brought it up, and this is still y equals. So to find y prime, we would bring that down. We'd get a negative 3x to the negative 1/2 minus 1 with a common denominator would be a negative 3/2. Just a little refresher there. You'd be surprised how many people are in calculus and still have a phobia of fractions. Fears are unhealthy. At least most fears are unhealthy. You should fear walking head first into a bus that's, traveling down the road, but fear of fractions, that doesn't make sense. So just conquer your fears, face them, deal with them, and you'll find yourself a better person for it. So here we have minus 12x to the negative 4, and then when I multiply this, I'm going to get a positive. That would be like 2 over 1, negative 2 over 3. There's nothing to cancel, so multiply directly across, and you get a negative 4/3 x to the negative 5/3. Okay, that's just subtracting 1 from here. Alright, and then since we didn't have negative exponents to begin with, we can bring them down. If you want, you can write them as radicals. I'm not going to do that. Oops, it's not 32, it's 3/2. Let's bring the screen down a little bit more so you can see it. And at this point, if there was anything that could have canceled, you cancel it. Alright. Again, we just did algebra step. Then we rewrote them by bringing them, actually the algebra step is over here, by taking the derivative, and then after we took the derivative we did another algebraic step to get rid of the negative exponents. Alright. You won't believe how many people panic when they see a problem like this. Just because you're a big bad calculus student, don't forget basic algebra. Again, using that power rule, the power rule for converting radicals into fractional exponents. This is what you should get in the numerator, over x to the 2/5 in the denominator. And then, anytime you've got addition, subtraction in the numerator, only in the numerator can you separate them. So you can rewrite this as x to the 1/2 over x to the 2/5 minus x to the 1/3 over x to the 2/5. I'm going to go off to the side and do my fractions. So we've got a 1/2 minus 2/5, common denominator of 10. What did I multiply this 5 by to get that 10? I multiplied by 2, so I multiply the top by 2 as well to get a 4. Negative 4, both are negative. And then what did I multiply this 2 by to get the 10? By 5, so I multiply the top by 5. Give me a 5 minus 4 gives me a 1/10. Since the answer to that was positive, it goes in the numerator with the x to the 1/10, like that. And then let's see what happens with the we have oops, we don't need the x's when we're doing this, sorry. It's 1 o'clock in the morning. And 2/5. Oh, no, not 10 this time, 15. This is what happens when you're fatigued. You can't even do common denominators properly. 2 times 3 becomes 5, stuff like that. So in this case, if I do times 3, I get the negative 6 on top. Oops, this must be odd. And then times 5. So this is a negative 1/15. So we have successfully rewritten the y equation in terms of a single x's that now can use the power rule, and they're already on the top. So the derivative be 1/10 x to the minus 10/10 gives me minus 9/10, and then plus, because of this negative and this negative, give me a plus sign, 1/15 x to the, subtracting that gives me a negative 16/15. Both of those have negative exponents, so I'll bring them down and make it 1/10 x to the 9/10 plus 1/15 x to the 16/15. It's a sloppy x. Sorry about that. Actually, all that's kind of sloppy. Let's rewrite that. Alright, and that would be your derivative there. Alright, those are just some random examples. I hope they've clarified things. Make sure you check out the other derivative rules that will apply, including the product rule, the quotient rule, and if necessary, the trig derivatives, only for the science-based calculus, not for the applied calculus people. Alright, so again, make sure that it's in the numerator. Once it's in the numerator, bring the exponent down, subtract 1. Get rid of any negative signs by bringing them back to the denominator. Practice, practice, practice. Thank you and have a nice day.